Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we see the problem number 5, which is based on principle of mathematical induction of chapter method of induction and binomial theorem. The problem number 5 is 1 upon 3 into 5 plus 1 upon 5 into 7 plus 1 upon 7 into 9 plus dot dot to n terms is equal to n upon 3 bracket 2n plus 1. So we have to prove this problem by using principle of mathematical induction. Now let's see the solution. First of all, the given problem we denote as a P of n, that is P of n equivalent to 1 upon 3 into 5 plus 1 upon 5 into 7 plus 1 upon 7 into 9 plus 2 n terms and that equal to n upon 3 bracket 2n plus 3. Then step number 1. Put n is equal to 1. LHS is equal to. So here we have to consider the first term on left hand side of problem, that is 1 upon 3 into 5. So that equal to 1 upon 3 into 5 gives 50. So that's about left hand side. Now consider RHS. Now right hand side is equal to n upon 3 bracket 2n plus 3. Here we have to put n is equal to 1. So we get 1 upon 3 bracket 2 into 1 plus 3. So that equal to 1 upon 3 in bracket. Now 2 into 1 gives 2 plus 3 and finally bracket complete. So is equal to 1 upon. Now 2 plus 3 gives 5 and 5 into 3 gives 50. So in this way we get RHS is equal to 1 upon 50. Therefore LHS is equal to RHS. It means the P of n is a true for n equal to 1. That is, P of 1 is true. Now we consider the step number 2. Here we have to consider that P of n is a true for n equal to k. That is 1 upon 3 into 5 plus 1 upon 5 into 7 plus 1 upon 7 into 9 plus 2 n terms is equal to n upon 3 bracket 2n plus 3. Now in this case we have to put n equal to 1. But problem is that we don't know the last term, that is nth term. So first of all we find nth term here. Now here we have to observe the numbers which are present in denominator at the first position, that is respectively 3, 5, 7. If you observe here, so this number forms an AP since the common difference is constant. So since 3, 5, 7 dot dot are in AP with first term A equal to 3 and common difference D equal to 5 minus 3, that equal to 2. Then for AP we write Tn is equal to A plus n minus 1 into D. So now here we write first of all Tn as it is. For A we write 3 plus n minus 1 into 2. So on simplifying further we get Tn is equal to 3 plus, now n into 2 gives 2n, then minus 1 into 2 minus 2. So in this way we get nth term as 2n, then 3 minus 2 gives 1. So here we get Tn is equal to 2n plus 1. Now here we consider the second numbers present in denominators, that is respectively 5, 7, 9 going on. So they also form AP with first term A equal to 5 and common difference D equal to 7 minus 5, that equal to 2. Then again for AP the nth term is given by Tn is equal to A plus n minus 1 into D, and therefore Tn is equal to, now for A we substitute 5 plus n minus 1 into, for D we write 2, and therefore Tn is equal to 5 plus, now n into 2 gives 2n, and then minus 1 into 2 gives minus 2. On further simplifying we get Tn is equal to 2n, now 5 minus 2 we get plus 3. So in this way we find the nth term of given problem. So it means now here the given problem can be written as 1 upon 3 into 5 plus 1 upon 5 into 7 plus 1 upon 7 into 9 going on. And for nth term we write respectively 2n plus 1 into 2n plus 3 is equal to n upon 3 bracket 2n plus 3. Now here we consider the step number 2. It means here we consider the result is a proof for n equal to k. It means in above statement we write n equal to k. So therefore we have 1 upon 3 into 5 plus 1 upon 5 into 7 plus 1 upon 7 into 9 plus going on plus 1 upon. Now whenever n we have to write k, it means we get 2k plus 1, second bracket 2k plus 3 and is equal to k upon 3 bracket 2k plus 3. Now let us this denote as a equation number 1. Now here we consider step number 3. We have to prove that P of n is true for n equal to k plus 1. That is 1 upon 3 into 5 plus 1 upon 5 into 7 plus 1 upon 7 into 9. Now whenever n we have to write k plus 1. So here we get 1 upon 2 bracket k plus 1 plus 1. Next bracket 2 in bracket k plus 1 plus 3 bracket complete is equal to k plus 1 upon 3 bracket again 2 in bracket k plus 1 bracket complete plus 3 and finally the square bracket complete. It means we have to prove that 1 upon 3 into 5 plus 1 upon 5 into 7 plus 1 upon 7 into 9 going on plus 1 upon. Now this on further simplifying we get 2k into 1 2k plus 2 into 1 2 and plus 1. So totally first bracket gives us 2k plus 3. If we simplify the second bracket then we get 2 into k 2k, then 2 into 1 2 and plus 3. So we get totally 2k plus 5 and that equal to k plus 1 upon 3 bracket Now 2 into k 2k plus 2 into 1 2 and plus 3. So that gives finally 2k plus 5. So this we have to prove. So here we start from LHS. So left hand side is equal to 1 upon 3 into 5 plus 1 upon 5 into 7 plus 1 upon 7 into 9 going on plus 1 upon 2k plus 3 first bracket 2k plus 5 second bracket. So that equal to now 1 upon 3 into 5 plus 1 upon 5 into 7 plus 1 upon 7 into 9 going on plus. Now here first of all we write the second last term. So if you observe here, the terms which are present in the denominator, they have a difference of 2. So the second last term is 1 upon 2k plus 1 and second bracket 2k plus 3 plus the last term is 1 upon 2k plus 3 first bracket and 2k plus 5 second bracket. Now here we make the bracket from 1 upon 3 into 5 plus 1 upon 5 into 7 plus 1 upon 7 into 9 plus dot dot plus 1 upon 2k plus 1 first bracket into 2k plus 3 second bracket. So here we have to close the square bracket. And for this square bracket which are we just close, we use equation number 1. So by using equation 1, for that bracket we replace k upon 3 bracket 2k plus 3 and plus we write 1 upon 2k plus 3 2k plus 5 as it is. So here we have to mention by using equation 1. Now here if you observe, so we get 1 upon 2k plus 3 common. So we have 1 upon 2k plus 3 in bracket we write k by 3 plus 1 upon 2k plus 5. So now on further simplifying, we have 1 upon 2k plus 3 in bracket. Now in bracket we have different denominator, so we go for cross multiply. So on cross multiplying we get k into 2k plus 5 plus 1 into 3 upon 3 bracket 2k plus 5. So that equal to 1 upon 2k plus 3 in bracket. So is equal to 1 upon 2k plus 3 we write as it is. In numerator we multiply this bracket with k, so that gives us k into 2k, that is 2k square plus k into 5 5k plus 3 upon 3 in bracket 2k plus 5 bracket complete. So this gives us 1 upon, now in denominator we write 3 in bracket 2k plus 3, first bracket 2k plus 5, second bracket. Now here the terms that present in numerator, that 2k square plus 5k plus 3, which is quadratic equation, and that we have to factorize. Since here the 2 into 3 gives 6 and we have to factorize 6 in such a way that the middle term is 5. So which gives us 2 into 3. So it means the terms present in numerator can be written as 2k square plus 2k plus 3k plus 3 bracket complete. Since 6 can be factorized as 2 into 3. So is equal to. Now here from first two terms we take 2k common. So in bracket we have k plus 1 plus, now the remaining two terms, that is 3k plus 3, we take 3 common. So in bracket we have k plus 1 and then whole thing divided by 3 bracket 2k plus 3 into 2k plus 5. So the next step will be, now from these two we take k plus 1 common. So we have k plus 1 and the remaining term is 2k plus 3 upon 3 in bracket 2k plus 3 into 2k plus 5. Now here we cancel the term 2k plus 3 from numerator and denominator. So we have k plus 1 upon 3 in bracket 2k plus 5, and that is equal to a required RHS. So in this way we proved left hand side is equal to right hand side. Therefore the statement P of n is a true for n equal to k plus 1. That is P of k plus 1 is true. Therefore, by using principle of mathematical induction, the statement P of n is a true for all natural number. So this is a required solution for the given problem. Thank you.